Hello everyone, I am Pritham. In this video, I'll teach you the introduction to IoT, and in this chapter, we'll go like IoT definitions, characteristics of IoT, physical design of IoT, logical design of IoT, IoT protocols, and also IoT levels and development templates. The definition of IoT goes like this. It is a dynamic global network infrastructure with self-configuring capability based on standard and interoperable communication protocols where physical and virtual things have identities, physical attributes, and virtual personalities. It uses intelligent interface and integrated into an information network, often communicate data associated with users and their environment. The characteristics of IoT is dynamic and self-adapting. What is self-adapting? Okay, so what is self-adapting? The IoT system which never share its user information or any things in the internet can be called self-adapting. Okay, it actually never share its personal information in the internet. What is self-configuring? Self-configuring means self-configuration is the process of interconnecting available element that will perform the required function at the desired performance level. Okay. So next one will be interoperable communication protocols. What is that? The interoperable communication protocol says that it is a ability of two or more devices, systems, or platforms or network to work in conjugation. Okay, that means whenever I go for more numbers of devices or systems or platform working together, that is called interoperability. So interoperability enables communication between heterogeneous devices. That means the devices may or may not be same kind. It may be different kind of devices or system in order to achieve a common goal. So this is also one important characteristics of IoT. The fourth one will be unique identities. That means each and every things in IoT or devices in IoT, it must have a unique code. That means particular perfect address. If the master device send information to a particular devices, then that particular device only access the information. No other devices can access the information. That actually the kind of security kind of thing. Okay, so as your mobile phone have a particular sim number, then when you dial to that particular sim number, and particular communication will be happen in between these two mobile number, not other mobile number. Okay, so this is called unique identities. So it is also integrated into information network. Obviously, when it is called an IoT, Internet of Things, then all the data actually handled with a remote server or in a cloud-based management system. That is why the characteristics of IoT also integrated into information network system. Okay, so if you go for physical design of IoT, will go like the things in IoT is usually refers to IoT devices which have unique identities and can perform remote sensing, actuating, and monitoring capability. Okay, things IoT, in IoT, things stands for it is a devices having a particular identity, a particular address, and it is connected to the internet. Okay, it can actually sense something remotely. That means the sensor is placed remotely and you can get the information from the remote sensor, and can actuate the devices, and it can monitor the all the capabilities. Okay, these IoT devices, it can exchange data with other connected devices and applications or appliances. Okay, data exchange can be possible in IoT. Okay, IoT can collect data from other devices and process the data locally. Okay, the IoT devices can collect the data remotely, and it can process the data remotely, or it can process the data locally also. It can send the data to centralized servers or cloud-based application. Okay, so it can perform some tasks locally and other tasks with the IoT infrastructure. If the local processing is possible, that means if it require very less memory for processing the data, then the data can be processed locally. And if actually needed more data, more server, then it can process remotely also. Okay. So next we'll go for generic block diagrams of IoT devices. We know that IoT, as it is connected to the internet, it must have a connectivity port, and it must have some sensor port, some actuator ports, and all those things. Likewise, this in this slide you can see you have 7 different color block which actually retain connectivity, processors, audio video interface, IO interface, memory interface, graphics, and storage interface. So an IoT devices may consist of several interface for connection to other devices, both wired and wireless. Okay, the IO interface for sensors, interface for internet connectivity, memory and storage interface, audio and video interface. So the topmost layer will be connectivity. In connectivity you can see that it is a USB host and Ethernet. Okay, and then we'll go for processors. Processor stands for CPU. All the processing work will be done here. Then we'll go for audio video interface. Here you can go for HDMI cable, high definition multimedia cable, 3.5 mm audio. Here you can see the audio port, and RCA video, the 3-channel RCA. One is responsible for video, and two other responsible for left side and right side audio. Then memory interface you can get, and a NAND gate, NOR gate, DDR1, DDR2 is called RAM, random access memory. Then we'll go for GPU, that is graphics interface, graphics processing unit. Then we have storage, external storage. You can go for SD card, MMC, and SDIO cards. Okay, then after, if you make some inter-chip communication or inter-board communication, then you can go for UART, universal asynchronous receiver transmitter, SPI, I2C bus, CAN controller. All the things are actually called generic block diagram of IoT devices. Okay, so next will we go for IoT protocols. What is protocols? The way it can communicate to other devices, that is called protocols. It have some standard. Okay, if you follow some protocols, then you and the receiver will understand what the message will be. Okay, so in IoT protocols, actually the protocols are actually divided into layers. In which layer which kind of protocols will work, in which layer another protocols will work. So the IoT layers will be 4 layers. The first one or downmost layer will be the link layer. Okay, this link layer and second layer will network layer. These two are actually basically the hardware level layers. Okay, then we'll go for transport layer. Third layer will be transport layer. Fourth layer will be application layer. Okay, so the link layer, the first layer, it can connect Ethernet, Wi-Fi, WiMAX, 2G, 3G, 4G networks. When you go for the next level, that is network layer. In network layer, it's called internet layer. Okay, in this internet layer you can go for IPv4, IPv6, and all those things. Then you go for transport layer, you can see TCP and UDP protocols. Then finally, if you go for application layer, it consists of completely software layer. You can go for HTTP, COAP, WebSocket kind of protocols, DDS, AMQP. So all these protocols are divided into this layer. That means if you want to use HTTP protocols, you must use application layer. Okay, so if you go for a network layer, HTTP protocol will not work in network layer. Okay, so likewise the protocols are divided for with respect to its actual layers. Okay, so next go for logical design. We can see a block diagram in the right side. It consists of 6 different blocks. The logical design of IoT system refers to an abstract representation of the entities and process without going into the low-level specification of implementation. Low level stands for the circuit level implementation. So do not bother about the circuit level. For example, you buy an Arduino board. You can buy a Raspberry Pi board. So you do not bother about the circuit level information of Raspberry Pi or Arduino board. You just program it and do your work done. So this is called logical design. An IoT system comprises of a number of functional blocks that provide the system and the capability of identification, sensing, actuation, communication, and management. Okay, so the application means it will do the applications management, it can coordinate all the things, service, security is more important things. Okay, that means if you design some system and your system is not actually going for security, then everyone can access and you can hack the systems. So communication is more important thing, as it can communicate between devices and the internet, and it also have some devices, that is the sensors, actuator, and the receivers, all the things. Next lecture will go for the communication model. Thank you so much.